So let us begin with atom. So in this particular lecture, which is the first lecture for the development of atomic theory, I am briefly discussing the timeline, and we will be discussing in brief about the discoveries that led to the final model of the atom as we know today. So we are discussing the timeline for development of atomic structure. So if we begin with this, the first thing that we discuss about, the first person in this scenario will be Democritus. So Democritus can be regarded as an older scientist. So he was a Greek philosopher who used the word atoms for the first time. Along with this, I am also mentioning the Indian sages who have used the word Anu and Parmanu in the Vedic literature. But if we come to the modern day, so then the first thing was done by John Dalton. So John Dalton in 1808 proposed the postulates for the development of an atom. So he first of all he is the first scientist who gave us the postulates for the atomic structure. So I am stating some of his postulates. The first one is matter consists of small indivisible particles called as atoms. Atoms are neither created nor destroyed. Atoms of the same element are alike in every aspect and differ from atoms of all the other elements. Atoms combine with the other atoms in simple whole number ratios, forming compound atoms or molecules. An atom is the smallest unit of matter which takes part in a chemical reaction, and all chemical changes results from separation or combination of atoms. So these are the John Dalton's postulates for atomic theory, which greatly differ with the modern atomic theory. If I state some points regarding this, so John Dalton suggested that the atoms are small indivisible particles called atoms, but in the modern atomic theory, we have already established that atoms are divisible and destructible in nature. Then in the next point is Dalton stated that an atom is the smallest indivisible particle of an element, but the atoms are further subdivided into subatomic particles, which we refer as electrons, protons, and neutrons. In the next aspect, John Dalton postulates suggested that atoms of the same elements are alike in all aspects and they differ from the atoms of the other elements. But again, it is established in the modern atomic theory that atoms of the same elements may not be alike in every respect. That is, there is a possibility of the existence of isotopes. So they will have the same atomic number but different mass number. So there is a mismatch between the John Dalton postulate and the modern atomic theory, but it is one of the important findings in the development of atomic model, because without the postulates of John Dalton, nobody would have thought about the existence of atom. So that is the reason that we credit the works of John Dalton, who laid the foundation for the development of atomic theory or the modern atomic theory. So the next that we are discussing about is the discovery of electrons. So now how exactly this happened? So basically there was an experiment which was conducted by English physicist William Crookes in 1878, and this is referred as the cathode ray tube experiment, in which the discovery of cathode rays was done. Cathode ray tube experiment, which led to the discovered cathode rays, which led to the discovery of cathode rays. Later, in 1897, Sir J. J. Thomson studied the constituents and characteristics of cathode rays, and he concluded that there are negatively charged particles called as electrons. And he concluded that there are negatively charged particles called as electrons. So Sir J. J. Thomson led to the foundation of the electrons, and very soon, with the oil drop experiment, it was established that the mass of the electron is equal to 9.107 into 10 to the power of minus 28 gram, and the charge on an electron is a negative charge of minus 1.6 into 10 to the power minus 19 coulomb. So this was discovered, and this is the complete theory for the discovery of electrons, wherein first of all cathode ray tube experiment was performed by the William Crookes, followed by the work of J. J. Thomson, and along with the Millikan's, where the oil drop experiment was performed to discover that the mass of electron is 9.1 into 10 to the power minus 28 gram, or 9.1 into 10 to the power minus 31 kg, and the electronic charge was calculated to be minus 1.6 10 to the power minus 19 coulomb. Now post this came the discovery of protons. So post this comes the discovery of protons. So now what exactly happened is Goldstein observed that just like cathode rays, there is also a possibility of anode rays, and these anode rays were observed to be positively charged rays, and they were referred to as the positively charged particles called as protons. So Goldstein discovered protons with the help of anode rays, and it was seen that the mass of proton is equal to 1837 times the mass of an electron, and it was turning to be equal to 1.67 into 10 to the power minus 24 grams, and it was observed to be the positively charged particles. It was observed to be positively charged particles having a positive charge of plus 1.6 10 to the power minus 19 coulomb. Now post this comes the discovery of the atomic model by Rutherford. In the gold foil experiment, from a source, alpha particles are striking a gold metal plate. Now, it is very important that you understand few things about alpha particles. Alpha particles are positively charged particles. This is the first thing which must be kept in mind. The next thing which must be kept in mind is they have penetrating property. They can penetrate through matter. That is, this is a very thin gold foil
Now, why we are using gold over here? The choice of gold is also because of the fact that gold is the most malleable element on the surface of earth. इसका मतलब हो गया कि अपने गोल्ड को पीट पीट के एकदम पतला बना सकते हैं. तुम ऐसा ऑब्जर्व कियोगे कि जब अपने मिठाई वगैरह खाते हैं तो उसके ऊपर एक सिल्वर का कोटिंग रहता है, अपने उसको बरक बोलते हैं. तो गोल्ड को उससे ही पतला बनाया जा सकता है, उसको पीट पीट के और पतला बना दिया गया है. तो इट इज द मोस्ट मेलिएबल एलिमेंट ऑन द सरफेस ऑफ अर्थ. तो अपने बोलते हैं क्योंकि ये मोस्ट मेलिएबल था इसीलिए गोल्ड का इस्तेमाल किया गया. एंड अल्फा पार्टिकल्स वेर bombarded on the gold foil. Now what was the observation? The observation was something like this. He observed that the majority of the alpha particles went straight without any deviation, without much deviation. The alpha particles went through the gold foil. A very few alpha particles showed some deviation, like you can see over here. Some alpha particles showed some deviation, and a very few, matlab 1 out of 50,000 alpha particle bounced back. So over here, I'm also demonstrating in one more diagram that most of the alpha particles went without any deviation. A few alpha particles were deviated like this, and very few, that is 1 out of 50,000 alpha particle bounced back. And hence the following things were uh, concluded. Now, what was the conclusion part? The atom consists of a large empty space inside the nucleus. So there is a large amount of empty space inside the nucleus where there is neither proton nor electrons are there. So and hence जो अल्फा पार्टिकल यानी कि जो पॉजिटिवली चार्ज पार्टिकल था वो एकदम उसके थ्रू चला गया बिना किसी डेविएशन के, बिना किसी ऑब्स्ट्रक्शन के. देयर इज अ पॉजिटिवली चार्ज मास एट द सेंटर ऑफ द एटम. अब ये वाला बात से कंक्लूड होता है कि जो वेरी फ्यू यानी कि 1 आउट ऑफ 50,000 जो अल्फा पार्टिकल बाउंस बैक कर गया वो बाउंस तभी कर सकता है व्हेन देयर इज अ डेंस पॉजिटिव चार्ज एट द सेंटर ऑफ द न्यूक्लियस. And hence he said that there is a positively charged mass at the center of the atom. And this is what I was saying, very dense. The size of the nucleus is very small compared to the size of the atom. So there is a dense positive charge nucleus which is situated at the center of the atom, and the electrons revolve around the nucleus at large distance from each other and from the nucleus. And this is the reason for which the few alpha particles were deviated from their path, because the negatively charged electrons were attracting them towards them, and hence few alpha particles got deviated from their path. So Rutherford came up with this idea that there is a dense positively charged particle at the center of the atom and the electrons are revolving around it. Now with this he gave the idea something like this, that the electrons are revolving around the nucleus. But the problem was, if an electrically charged particle is rotating and it is radiating energy, that it is losing energy, then very slowly the electron will collapse and fall into the atom's nucleus. But this doesn't happen. बोलने का मतलब ऐसा हो गया कि अगर तुम अपने हाथ में एक थ्रेड ले लो, उसकी एंड पे अगर एक स्टोन में बांध देता हूँ और अगर उसको अपने घुमाना स्टार्ट करते हैं और अगर मैं उसका स्पीड धीरे धीरे करके कम करूंगा तो क्या होगा? द स्टोन विल फॉल बैक एंड हिट अस ऑन द हेड. तो ये वही वाला बात हो गया कि इलेक्ट्रॉन को अगर अपने इस तरीके से फ्लो करवाएंगे और अगर बोलेंगे कि ये एनर्जी रेडिएट कर रहा है, ये घूमते 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 अगर एनर्जी अपना लूज कर रहा है, सो डेफिनेटली इलेक्ट्रॉन मस्ट फॉल इनटू द न्यूक्लियस. लेकिन ऐसा तो होता नहीं है. एंड हेंस जो रुदरफोर्ड का जो मॉडल है वो यहाँ पे स्टेप ये फ्लॉ है उसमें, ये ड्रॉबैक है उसका, और वो यहाँ पे क्या है, वो खारिज कर दिया जाता है उसके मॉडल को और फिर दूसरा मॉडल अपने लेकर के आते हैं. तो ये बात इंपॉर्टेंट है. इसका बात सही कहाँ का था? सही बात भी है रुदरफोर्ड का सही बात क्या है कि एक डेंस न्यूक्लियस है जिसके अंदर प्रोटॉन्स है. इलेक्ट्रॉन न्यूक्लियस के बाहर यानी कि कहीं दूसरे डिस्टेंस पे घूम रहा है बाहर की तरफ. कैसे घूम रहा है वो रुदरफोर्ड नहीं बताया. वो जो बात बोला वो गलत इसलिए साबित हो गया बिकॉज अगर वो एनर्जी रेडिएट कर देगा so the electron will fall into the nucleus. So this was the drawback of Rutherford's model. So over here let us look at the Rutherford model back again in a very close way. So this is here a gold foil sheet which is placed, and this is the alpha particle emitter which we are going to bombard on this screen. These are the atoms we are talking about, where the central points are representing the nucleus of the atom, and the shells around here are representing the electrons in which the electrons are revolving around it. So this is how we are going to understand the Rutherford Goldfoil experiment. Now these alpha particles bombarded, as you can see, uh, are passing without any deviation. Majority of the alpha particles are passing without any deviation, a few alpha particles are getting deviated as they pass through this electron cloud. So from here we say that the electrons are on the outermost shell, and very few alpha particles experience a very high deviation because of this centrally located nucleus. We can say as the alpha particles are approaching this nucleus, they are getting repelled by this particular nucleus. You can focus here also, they are getting repelled from here as well. So this is what the he demonstrated, that the alpha particles, if bombarded towards the nucleus, then they are going to experience a strong repulsion from the centrally located nucleus, and the electrons which are on the outermost shell are attracting the alpha particles towards them, accounting to slight deviation in their path. But since the atom is empty on a whole, so the majority of the alpha particle passed without any deviation. So these are the assumptions and the results of Rutherford's gold foil